Division of polynomials is a bit of a process that has some similarity to the process for dividing numbers by long division. So we're going to start with an example with numbers. First of all, a little bit of language. This number on top is called the dividend. The number on the bottom that we're dividing by is called the divisor. So the way that we start one of these long division of numbers problems is generally that we put the divisor on the outside, we have our division bracket, and we put the number on the inside. Then we start the division process, and the first thing we do is we find, starting from the left in this dividend, the smallest part that we can divide by 8. 46 is divisible, not divisible, but it is bigger than 8. So we check how many times 8 goes into 46, and that would be 5 times. We put that over the 46, and then down here we calculate that 5 that we just found times the 8 that is our divisor, and we write the result underneath. So that's our 8. This is our 5, and we put underneath this the result 40, and in the next step, when we go downwards, we make sure to subtract. Always when we go down, we subtract. The result of this subtraction then is 46 minus 40 gives us 6, and we bring down the 7 to get the number 67. At this point, we start the process over again looking at kind of the smallest number here, which in this case turns out to be the whole thing, 67. We divide that by 8, and 8 times 8 is 64, so that's the closest we're going to get. This 8 then we bring down and again multiply by our divisor. Divisor of 8. And we put the result under 67. This 64 again gets subtracted as we go downward. So that we finally get to a value of 3. And we give this 3 a name also. It is called the remainder. This number up here on the top that we just calculated is called the quotient. And what we do with numbers is we end up writing this as a mixed number with the quotient first, followed by the remainder over the divisor. What we're going to do with polynomials is mimic this process, but how we interpret each step in some cases is a little bit different. So we have some steps outlined here. But the first thing we're going to do is identify the dividend and the divisor from this expression here. That polynomial on top is my dividend. So it's the one that goes inside the bracket. And the x plus 1 on the bottom is my divisor. This is the one that goes outside the bracket. So my first step, and I'm going to leave a little bit of room above it, my first step is to set this up as x plus 1 into 2x squared rather, plus 3x plus 5. All right, so now let's compare this to what we did with numbers. We have done our first step here. We have set this up as divisor into dividend. My second step said we're going to find a term in the quotient by dividing the first term of the dividend by the first term of the divisor. So this is the main step that differs a little bit from how we did things with numbers. Up here, this is where we took 46, which was a portion of our dividend, and we divided it by our whole divisor, 8. Down here in our polynomial example, we're going to start by taking just the first term and divide it by just the first term, because what we're after here is a single term for the quotient. So my calculation up here, I'll write tiny way up high, 2x squared divided by x gives me, I can see that the x squared divided by x is just x and the 2 remains. So this first term in my quotient is 2x. I again look at what I did with numbers to see that my next step was to take that and multiply it by the divisor. I'm now at this stage right here where I brought down the 5 that I had just calculated and I multiplied it by 8, which was my divisor. At this stage I do bring in the whole divisor, not just the first term. So my next step is to take that 2x that I just calculated, writing off to the side here, multiply it by the whole divisor, x plus 1, and put the result underneath my dividend. Distributing in, that gives me 2x squared plus 2x. This is just the distributive law that I'm using here to eliminate the parentheses. In my next step, just like I did in the above example, I am going to subtract downwards And when I subtract, I want to make sure that I am subtracting the whole thing in parentheses. So I'm going to put parentheses around it and in a different color a minus sign on the outside. And I need to be very careful about my signs during this step. 2x squared minus 2x squared, those drop out completely. And this should happen every single time. It's the nature of how we calculated this that we will reduce a term with each step. Then the next one we have is 3x minus 2x, which gives me simply x. And similarly, I'll bring down my plus 5 so that my dividend is now x plus 5. I have now done one complete rotation. I'm just ready to repeat the process. Looking at my dividend now, starting over again, my first step is to find a term in the quotient by taking just the first term of the dividend and dividing that by just the first term of the divisor. So that gives me x over x, which is 1. And each of these terms in the quotient get added, so it's very important to write that plus symbol there, not just put in the 1. Usually when it's negative, people get the symbol there automatically, but when it's a plus, sometimes people miss it. And again, I bring down that 1 that I just calculated. I multiply it by the whole divisor, and I write it below. Of course, this was multiplication by 1, so nothing really happened. I write it below my dividend, and again, I'm ready to subtract. Every time I'm going downwards like this, I subtract, being careful to put the whole polynomial in parentheses and put a minus sign out front of it, and to be very careful about my signs during this step. Our first example doesn't get very tricky with the signs because we need to build up to that slowly. Everything is positive here. It does get a little trickier when we have negatives, subtracted from negatives, etc. Again, in our very first term, x minus x, these will drop out. And the second term becomes 5 minus 1, which is 4. This 4 is now my remainder. And I'm going to write my answer as quotient plus remainder over divisor. This 2x plus 1 is my quotient. So when I write my answer in this form, quotient plus remainder over divisor, it looks like 2x plus 1 plus line. My remainder is 4, and my divisor is x plus 1. This is now my final answer. A few points, however, before we go further. It's important not to gloss over exactly how I knew that I was done and that that's my remainder. I got all the way down to a number, but that won't always be the case. So let's look down here at our work in dividing these polynomials. What it really comes down to is the degree of the polynomial. My divisor is a degree 1 polynomial because x to the 1, that's the highest power. So I had a degree 1 divisor, and my remainder is degree 0. I know that I'm done when the degree of my result is strictly less than the degree of the divisor. It can't be equal. In the last step, when I had x plus 5, I had the same degree. I could keep going. So if you have a degree 2 divisor, you may find that your remainder is of degree 1 or degree 0, depending on what happens to drop out in that last step. But you know that you're done when the degree of what you have remaining is strictly less than the degree of your divisor.